Hey everyone, today we'll be going over LeetCode problem 208, implement trie. And a trie is also known as a prefix tree. This is another problem off the Blind 75 list, which is a list of problems commonly asked during technical interviews. In this problem, we want to implement a prefix tree. And this is a data structure which is used to efficiently store strings. Now, applications for tries or prefix trees include autocomplete and spell checker. Now what we want to do is implement these four functions. We're going to have to implement the constructor for the trie. We're going to have to implement the insert function, which inserts a new string into the trie. We're going to implement the search function, which returns a Boolean true or false based on whether or not the word that we are looking for is in the trie. And then another function starts with, which checks for prefixes in the tree. It also returns a Boolean, and so it will return true or false whether or not we have a word which starts with the given prefix in our trie. So I have a few function calls here as an example, and we're going to run through them together. Now we start off by calling the constructor for the trie. Now when calling the constructor, what we're going to have is simply an empty node, which will be the root of our tree. And this is what will be created when calling the trie constructor. Now when going to insert words into this trie, each and every character of the word will be inserted as a child starting from this specific null empty trie node root. So for example, we have next to insert paper. Now what we will do is look to see if this node has any children with a P. It does not, so we will create a new trie node, which will be the child of this root node, and it will have inside a P as a character. We then continue on. We have not completed with this string, paper, so we would then go add an A as a child of this P. And this would continue on until we reach the end of the word. After having inserted each and every character of the word paper, we need something to mark the end of the word. So we know that this word paper ends with an R. And so we need to mark this R so that we know that it marks the end of the word paper. And the way we will do this here in representing it is we'll just create an asterisk here at the side of the R. We now have to insert the word pencil. Now we start again from this root node, and we check to see if it has any children with the letter P. And it does in fact have a P as a child. So we do not need to insert a new node with the letter P as the child of the root node. Then when moving from the P, we need to check if this P has any children with the letter E. And it does not. So we must once again create a child from this P, and this will have as its character an E. We then look after the E, we have an N, so we check to see if this E has any children with an N, and it does not, so we must once again create a new node with that N. And we do the same for the remaining characters. After having inserted every character of the word, once again we would mark the L so that we know that it is the end of a word. We now want to search for the word pencil in our trie. So what we would do is we would start from the root. We check to see if we have a child with the letter P, and we do. Then we check to see if from this P we have a child with an E, and we do. We look for an N as a child and find it. Same with the C, same with the I, and then same with the L. However, we must also make sure that this L does in fact mark the termination of a word, and it does. Therefore, for this search, we would return true. We do have the word pencil in our trie. Now let's attempt to search for the word pen. Once again, we'd start from the root and look for a P as a child, and we find it. We look for an E from here, and we find it as a child of P. And then we look for an N from here and find it as a child of the E. However, when going to make sure that this N marks the termination of a word, we see that it has no asterisk. Therefore, We actually do not have the word pen in our try. We have a word which starts with pen, but we did not actually insert the word pen itself. Therefore, for this search, we will return false. We next look to see if we have pen as a prefix in our tree, or if we have a word which starts with pen. Now, because of the process from before, we know that we have a P starting from the root, an E, and then an N afterwards. And because we are only looking to see if we have pen as a prefix or a word which starts with pen, we do not need to look for the asterisk. Therefore, for this case, we would return true, because we do have a word which starts for pen. Pen is a prefix in our tree. Next, we insert the word book. So we start from the root once again and look for a node which is a B as its child. We do not have one, so we must create that. And once again, we'd put in this node a B. And following this, we'd look for a child from the B, which has an O as its character. And so we would go on and insert all of the characters in the tree. After inserting the characters, we would once again mark the K as the termination character, so that we know that we inserted the word book specifically. Now we're looking for a word which starts with the letter C. We start from our root, and we check to see if it has a C as its child, and it does not, so we would return false. Finally, we're looking to see if we have the letter B as a prefix, and we start from the root, see if it has a B as its child, and it does. Therefore, we return true. And this is how a prefix tree works. Basically, it reuses prefixes, so we do not have to reinsert nodes with the same characters, and it allows for quick lookups when looking up based on prefixes. We saw, for example, when we looked for a word which starts with the letter C, if we had a list, an array of all the words, we would have to look through every word one by one and see if we have any word which starts with the C. That would take linear time, and so if we had a million words in the array, it would take a million steps to find and see if we have a word which starts with a C. Instead, with the try, if we're looking for a word which starts with a C, what we're going to do is basically give every node a map, and each node will have a map of its children. And so what we're going to do is basically look up in this map if we have a child with the letter C. And we'd see simply with one lookup in constant time that it does not, and it would give us the false that we need. Whereas with the array, we would take linear time to look through each and every word. And this is why tries can be very helpful. And so when analyzing the runtime for each and every one of these functions, we know that the constructor will take constant time because all we are doing is creating a root node. The insert function will take linear time with respect to the length of the string that we are entering. So for example, for paper, if n is the length of paper, which is equal to 5, we know that that n will be the runtime for the insert function. Because at each point, what we're doing is checking to see if we have the child with the character needed already in our tree, and we can do that lookup with a constant time. And if it is not there, we would create a new node with that letter. And then we do the same for each and every letter in the word paper. So we know that that would take 5 steps. So it's linear with respect to the length of the character. Now, when going to search for the word, we know that this is also linear with respect to the length of the word. So if the length of the word is n, it will be O of n. And this is because at each point, what we're doing is checking to see if the node has a child with the character needed. And each of these lookups can be done in constant time, but we are doing it for each character. So it will be O of n time. And same thing with the starts with function. It is also linear because the only difference compared to the search function is that we do not have to look to see if the last character has that asterisk or the mark to say that it is a termination character. So we know therefore that the 3 functions insert, search, and starts with in the try work in linear time, and the constructor is a constant time call. Let's now go on to write up the code. Now, before starting off the code to implement our try class, we know that the try is going to be consisting of try nodes. So we need to implement this try node class. Now, when calling the constructor for the try node class, we know that what we want each node to have is a map of its children. So we're going to give it a property called self.children, and we're going to set it initially equal to an empty map, because when the node is created, it has no children yet. And then initially, we want to say that it does not mark the end of the word. So each try node will also have a property self.endword, and it will initially be set to false because the node at construction will not mark the end of a word, but this value can be modified to be true if this character does eventually mark the end of a word which is being inserted. Now for the constructor of the try class, we know that when creating a new try, all we wanted to do was create its root node. So we're going to give it a property called self.root, and this root node we said is going to be an empty, a null node. Initially it will have no children. Its self.endword will be equal to false as marked in the try node class, and this node has no character within it. Now we can move on to the insert function. We know that initially when inserting a word, we're going to start from the root. So we're going to declare a pointer cur and set it initially equal to the root. So this cur will be looking at one node at a time. Now for each character in the word that we are inserting, we want to see if this character is or is not in the children map of the current node. So if this character is not in cur.children, meaning that the current node does not have the character we are looking for in the children map, then we know that we need to create a new node as its child with the needed character. So we can say cur.children char is going to be equal to a new try node. And so we're basically inserting into the children map for this specific current node a key value pair, where the key is the current character in the word, and the value is a new try node. However, if this current node already has as its child the try node with the needed character, we can just move the pointer along to that child by saying cur equals cur.children with the key of character. So we do not need to create the new node in that case. Also, when we're done with the word, so we're done with the entire for loop, we have inserted the entire word, we know that at this point we must mark the current character as an end word, and so we can say that cur.endword is equal to true. We now move on to the search function. Again, what we need to do is initially when searching, set our pointer to the root node, and then we want to check to see if we have each and every character needed as the child starting from that point. So for every character in Word, if the character is not in the child map of the current node, then we know that that means that we do not have the word in our try, and so we can return false. Otherwise, if we find the new character that we need, then we can move our pointer on to the next character. So we're going to say cur is equal to cur.children, and the key is the character. And if we actually reach the end of the word, we return true based on whether or not this last character marks the end of a word. So we will return cur.endword, meaning if the character we are completing at marks the end of the word, we will return true, otherwise we will return false. Now the starts with function only looks for a prefix, so it will basically be the same as our search function, besides this last line which returns based on cur.endword. So again, we're going to start our pointer out at the root. For each character in the word, we're going to check to see if we have a node with the needed character as a child of a current node. And so if char is not in cur.children, we're going to return false. Otherwise, we're going to move the pointer along to the next node. So cur.children. And at the end, we do not need to return based on whether or not the final node marks the end of the word. If we have found the last character, we can then simply return true, because we don't care in that case if that node, if that character represents the end of a word. And this would complete our entire try class implementation. So let's make sure this runs. And we see that we have a typo. Here we are receiving not a word, but a prefix. So let me just go and change that in the function. And let's see if it runs again. And it works efficiently. Thank you so much for watching this video. If you enjoyed it, please like it and subscribe to my channel. I'll see you on the next one.